Now, let's talk about a couple more examples with volumes of rotation. So, example number 1, we have just y equals square root of x, and x is between 0 and 4. Just by knowing this function, this looks like this. So we know this is a washer. Okay? No, this is the disk method. Okay? So, if you rotate around the x-axis, that's what we have. Okay, between 0 and 4. So rotating around the x-axis, my rotation is going to be like this. And because it's rotating around the x-axis, it's going to be perpendicular. Those are my cross-sections. So my area here is equal to pi times f of x squared. That means my volume is equal to between 0 and 4 of pi times square root of x squared dx. Okay, that's the volume for this one. Now for this one, it's integrating with between 0 and 4, and then says rotating around the y-axis. In that case, between the x, this is the x-axis, and the x-axis, and this is going to be the y-axis. So that means my area, well, knowing this, I'm rotating around this direction. Okay, that's what it looks like. So rotating this way, so that means my cross-section is going to be horizontal. So that means we got to rewrite our equation. So in that case, x is equal to y squared. So that means my area here is going to be, area is equal to pi times f of y squared. That means my volume is going to be pi between 0 and 4. Okay, I know this is 4. Is it 4? 4. Plug in 4, square root of 4. That's right, this is going to be 2. So between 0 and 2 of y squared dy. And whatever the answer is, that's going to be the volume. Now, next one we have e to the x, okay, in between 0 and 2. Again, it's just one function. That means we're going to be looking at, this is the disk method as well. Okay, between 0 and 2, this is e to the x between 0 and 2. That's what my function looks like. First of all, rotating around the x-axis, rotating this way. That means my cross-section is going to be vertical. Okay, that means we're integrating with respect to x between 0 and 2. So that means my area here is equal to pi times f of x squared. That means my area is equal to pi times f of x is e to the x, in that case e to the 2x. That means my volume is equal to pi between 0 to 2 e to the 2x dx. Okay? Now, if you're rotating around this one, okay, rotating around the y-axis, and it's formed between this region, so that means rotating this way. So this is my region here. So in that case, rotating this way, it's going to be horizontal. Okay, so that means my area here for this question, okay, we have to rewrite this function in terms of x, in terms of y, so it could be natural log both sides, you have natural log y equals x. That's my function. So my area in this case is equal to pi times f of y squared. So that means my area is equal to pi times my f, in that case, natural log of y squared. So that means my volume is equal to be between 0, well it's not 0, this part here, this point is going to be 1, all the way to e to the 2, okay, because e to the 0 is 1. So in case from 1 to e to the 2, multiplied by pi, and then you have natural log of y squared dy, okay, so that's that, okay. Now, there are three more examples here. So example number 3, we have y1 is equal to 1 half plus x squared. y2 is 1 half plus x squared. So drawing out my graph, my x is between 0 and 2. So that means this is what my graph looks like. And then this part here is equal to my f of x. So that means my f of x is equal to 1 half plus x squared. The bottom half is, the same function. Oh, this is y equals x. Okay, so g of x is equal to x. Okay, so again, we're rotating around the y-axis, the x-axis, going this way, so that means my cross-section is going to look like this. So again, two functions, you have poles, so this one here is going to be a washer method. Okay, so over here, so we have the top function with the bottom function. So my area is equal to pi times f squared minus g squared. So my top function is, well, let's write that, f squared minus g squared. That means we have pi times 1 half plus x squared minus x squared. In that case, my volume here is going to be between 0 and whatever this function, between 0 and 2. So this part here is equal to 2. So we have volume is equal to pi between 0 and 2. And then the top function minus bottom function, but both squared. So you have 1/2 plus x squared minus x squared dx. Okay, so that's my volume. Now, next one we have y1 equals square root of x, y2 equals x squared, and then let's rotate around the y-axis. Okay, y-axis, that means first of all, rotating around that way, signify that, because we're rotating this way, and we're talking about perpendicular, and it's a washer, so it's going to be horizontal. So, because we know this function here is x squared, so that means x is equal to square root of y. Again, we're taking the positive component because it's going to the positive direction of y. Okay, now this one here we have y1 equals x, so that means x is equal to y squared. Okay, so that means, again, the point of intersection is when they equal, so that means it's going to be 0, 1. So in that case, we're looking at this axis. So that means my area for this question here is A is equal to, so we have A is equal to pi times F minus G both squared. So that means my pi is equal to my, this is my F. So this is my F, and this is my G. So that means my F here is going to be square root of y, so square root of y squared, minus my bottom function is going to be y squared squared. That means my volume is equal to between 0 and 1, pi between 0 and 1, and we have y minus y to the power 4 dy. Okay, last but not least, we have example number 5, y1 is equal to x minus 1 squared plus 2, and the other one is y2 is equal to x, and x equals 0. So that means drawing the graph. Okay, so we have to go with the graph. This is what the graph presents. Between 0 all the way to 2. And then this is the top number. Now, so that means my function here is going to be the top function, my bottom function. So that means my top function here is going to be, this is my top function, f of x is equal to x minus 1 squared plus 2. My bottom function here is g of x is equal to x. Okay. So this is the region of interest, and we rotate around the x-axis. So what's what we have here? That means my cross-section is going to be vertical. So again, area of this is equal to pi times f of x minus g of x, top function minus bottom function, both squared. So in case f squared minus g squared. So in case you have pi times top function, which is x plus minus 1 squared plus 2, whole thing squared, minus my bottom function, which is x squared. So that means my volume is equal to pi between 0 and 2, and then we have x minus 1 squared plus 2 squared minus x squared dx. Okay, and that would be the answer. Okay, just go ahead and integrate that and you'll get the right answer. Okay, assuming your math is right. Okay, so that's basically a couple examples where the axis rotations on the x-axis or the y-axis. In the next video, we're going to talk about when you actually shift the axis rotation left, right, up, or down. Okay, so that's all for this one. Okay, see you in the next one.